My name is Michael Alexander-Ramos, and I'm an assistant professor in mechanical engineering at the University of Cincinnati. I've always loved vehicle design. My father was also an engineer as well. I kind of got an early start in being familiar about what the field was, and then it just kind of continued to build on from there with my experiences in high school physics and things that I did in undergrad all the way through graduate school. I chose University of Cincinnati for my undergraduate degree because of the co-op program, 100%. I saw that the co-op program was very well developed and well established, and of course it had solid academics as well too. In addition to that, also I had a couple scholarships, one of which was sponsored through the Emerging Ethnic Engineering program, and so between that as well as also the Darwin T. Turner Scholars Program, that made it very hard to pass up. That's what brought me here. My career path was a little bit more unconventional. I always knew I wanted to do something with vehicle design, but I actually started out working in industry. So I worked for about 4 years at General Motors Research and Development, and that gave me some very practical experience in the field. But I also always had some interest in getting back into the academy and being able to have the freedom to explore the design problems I wanted to. And so a combination of that, and also I'm very passionate about teaching students as well too. It just seemed like a very good mesh to come back to the academy. It is an amazing and both mind-blowing experience being an educator back at the same institution that I was once a student at. For one, some of the very professors that I've had now are now my colleagues. And I have certainly a whole lot more appreciation for the roles that they played when I was as a student, and it's great to be able to give back to so many programs. Among those as well too is the Emerging Ethnic Engineering program that I was involved with as an undergraduate student. The research that I'm working on right now does have real-world implications. Even while I was working at General Motors, one of the biggest problems they were trying to figure out at the time when they were developing hybrid systems, or quite frankly any propulsion system, was what was the best combination of engines and transmissions that they could pair together to achieve optimal fuel economy. Automotive systems are very complex things to design, and so they involve design decisions from engineering, business, policy, and even industrial design. There's a lot of subdisciplines and there's trade-offs among those. And so what we try to do is we resolve those trade-offs by using mathematical optimization algorithms to solve interesting design problems. Everything that we're doing right now is dealing with a combined design and control optimization framework. And so that is actually a growing field in a very hot area, and we see that we can tap into that in a lot of different industries, not just automotive. One thing that I'm really excited about that I'm working on is hybrid electric propulsion applications to aerospace systems. So I am not an aerospace engineer by background, but I'm aware of the fact that they are now looking at that technology as a possible solution for their energy efficiency needs. And so it's a learning curve for myself and my students, but we've still found this as an interesting problem of how do we again size the propulsion system components, and how do we come up with optimal control or energy management strategy to get the best fuel efficiency, if you will, for this vehicle.